Namaste. This is the first period for the topic irrational number. Welcome, students. Welcome to maths class. The topic is irrational number. It's day 1 for the topic. And here is the definition. Those numbers which are not rational are called irrational number. Irrational numbers are denoted by Q dash, okay? Q prime also you can tell. In other words, those numbers which cannot be expressed as the ratio, okay, the integers are called irrational numbers. Okay, here we can write ratio of the, okay, here we can write ratio of the integers are called irrational number. Square root 2, that one, square root 2 value, if you find in decimal, it will come 1.41, okay, and 21356 dot dot dot, okay, and square root 3 1.73205. Actually this one, okay, I tell this one, whatever value is kept in square root sign, okay, if they are not coming outside, okay, if they are not coming outside, if they do not move, okay, come outside the root sign, that is called radical sign, okay, then that is called surd, and all the surds are irrational number. Okay, all the surds are irrational number. Which remain inside the radical sign, okay, if they don't come outside, if they don't cancel, okay, root, and it doesn't come outside, then that is surd, and all the surds are irrational number. For example, this I told already, square root 2, square root 3, they are irrational numbers. Remember, the addition, subtraction, multiplication, and division of two irrational numbers are not always closed. For example, not always closed means when we add two irrational numbers, sometime answer may come irrational and sometime answer may come rational. That's why they are, look at it, telling addition, subtraction, multiplication, and division of two irrational numbers are not always closed. For example, look at sum of two irrational numbers and difference of two irrational numbers. Look, sum square root 3 1 irrational number plus minus square root 3 is another irrational number. When you add them, 0 comes. 0 is the what? Rational number. That's why irrational adding, sometimes it may come rational. Here difference, look here. When you subtract irrational by minus irrational, answer comes rational. Okay, but what happens sometimes? Look here, another one, square root 3 plus square root 3, 2 root 3. This is an irrational. Irrational adding with irrational make up irrational also. And irrational subtracting with irrational, okay, minus minus plus and square root 2 square root 2 square root 2. It may come irrational also. Number 3, product of two irrational number. And number of this one, okay, 4. Here must be 4. Okay, I'm keeping there. It's 4. Then look here, I was telling this one, product of the two irrational number and the quotient is division. When you multiply irrational with irrational, square root 3 with square root 3, which is rational. Sometimes square root 3 divided by square root 3, irrational divided by irrational become a rational number. There is square root 3, okay, and square root 3. When this is the multiplication one, okay. There came again another one, sign one. Then we have to write a multiplication here. Here must be multiplication sign. Multiply there, okay. If you multiply two irrational number, sometime answer may come irrational. They may be close, okay. And see here, square root 3 into square root 2, answer gives square root 6, irrational number. And square root 3 divided by square root 6 divided by square root 3, square root 2. When we divide irrational number by irrational, answer may come irrational also sometimes. Sometimes irrational, sometimes rational also. That's why they are not giving always the irrational one. Sometimes they may give the rational also. And true or false one here, okay. All the rational numbers are also irrational number. It's false. All the integers are rational numbers. It's true. The set of rational and irrational numbers are disjoint. Means there is no similarity. Okay. Rational is different. If rational means what? Those numbers are not rational. They all are irrational. That's why they are disjoint. True. The irrational numbers become non-terminating decimal only. It's false. Sometimes it will be, okay, non-terminating recurring also, okay. And the sum of two irrational number is always a rational number. Just I told, not always a rational. Sometimes it may be not always irrational. It may be rational also sometimes. That's why it is false. And this continue. The product of two irrational number is not always an irrational. Yes, it is true, because sometimes it may be rational also. Number 7. The square root of integer is always an irrational number. It is false, because square root 3 is irrational, because 3 does not come outside the root sign, okay. But square root 4, it will come 2 outside, okay. Square root 4 means, that's why sometimes what is the square root of integer is always an irrational? Not. Sometimes it may be rational also. That's why it is false. And which of the following are rational, okay, or irrational? Write the reason also. 1 by 2. 1 by 2 is in the form of p by q, and q is not equal to 0. So 1 by 2 is rational number. Square root 2. Here square root 2 is not in the form of p by q form. Okay, so square root 2 is irrational. We can tell square root 2 is so, then it is irrational also, we can tell. Okay, it doesn't come outside the root sign. Number 3. Square root 7. Square root 7 is also irrational because it doesn't come outside the root sign. Okay, that also can, or you can write this reason also. Square root 7 is not in the form of p by q, so square root 7 is irrational number. 5 by 2. Here 5 by 2 is in the form of p by q, and q is not equal to 0, so 5 by 2 is the rational number. 0.25. 0.25 means here 25. This root cancel, then this, decimal cancel, then what comes down? 100, because after decimal there is 2 digits, then 2 0 will be there. And 1 by 4, it means 1 by 4 is in the form of p by q, and q is not equal to 0, so 0.25 is the rational number. Your assignment, you have to revise and practice all these activities, okay. That is your work of today, okay. Thank you very much. Stay safe, healthy and happy. Bye bye.